Hold on 2 seconds. Right, how are we all doing? I'm going to explain how to do power supplies, year one stuff again. So, um, obviously, power supplies start with diodes. Quick reminder: a diode obviously works by allowing current through one way and blocking it the other way. That's a normal silicon diode. They use about 0.7 volts. So they'll have 0.7 volts dropped across the diode. So if we took this top diode there, for example, if I close that switch, the current will come along here, go through there, through the lamp background. L2 would be off, lamp 2 would be off because obviously the current will go that way and it can't get through there. Okay, so that's just what diodes are. Hopefully that makes sense. Um, Remember, what the idea of rectifiers, full and half wave rectifiers, is to convert AC to DC. So this is an AC signal. Notice if you've got voltage on this axis, it goes up to about 340 volts, down to about negative 340 volts. That is exactly how much the voltage is in the UK. If you're using an oscilloscope and put it into a plug socket, that's what it would read. However, we talk about the DC equivalent voltage. We call it the RMS voltage, root mean squared. So equation on the data sheet, very simple, that the peak voltage equals the square root of 2 multiplied by the RMS value. In the UK, the RMS value is about 230 volts. If you did in your calculator 230 multiplied by square root of 2, you would get around about 340 volts there. Okay, it's on the data sheet. It's just a little conversion between the two. So we don't use a P, we use a little zero. Okay, that's all of that one. Moving on, moving on, moving on. I think, yeah, this is a half-wave rectifier. In fact, I'm going to show you doing this. I'm just checking I'm still recording. Yeah, still recording. That's fine. Good. Okay. So let's start with. I've just got a sine wave going in 50 hertz, 5 volts. I'm again a small signal going 5 volts. You can see obviously you've got a sine wave going in, which is the red signal. And if I'm measuring the output, which is across some form of load, I've got a 10k resistor there. You can see that obviously the positive half of the cycle will get through that diode, and it chops off the negative half. Notice it doesn't quite go up as high as the red signal because you've got 0.7 volts dropped across the diode. That's just circuit rules, series circuit rules. So you can see it's that. I look at that as like the Loch Ness Monster, I call it, because it's kind of, you can see the lump coming out of the water there. So there we go. So that's that one. If you have a capacitor there, so like that, hopefully you will see. Oh, let's make a bit more room. A bit more room there. So let's pop that there. So hopefully with a capacitor, you have the classic. Ooh, let's reduce that slightly because that resistance is so high, it's not showing you the ripple. There you go. You've got a kind of ripple voltage thing going on. I'll give you some, make it even smaller. Let's go half a 0.5k, shall we? So you can see it even more drastically. There you go. You've got this ripple voltage going on now. Okay. So essentially, what happens is the first half of the cycle, obviously, the capacitor is charged, and then at this point here, when the red line goes back down, the capacitor is fully charged, so the capacitor will now discharge, then it will get a kick and charge, and then it will discharge. Notice you can change the size of the ripple voltage by changing the capacitor value. Smaller capacitance, obviously you can have a larger ripple because it can't store as much charge, can it? Larger capacitance, smaller ripple. There we go. Okay, so there is a little bit about ripple voltage, which I'll show you in a moment. So that's the second case. You wouldn't use it in this case, but I'm just going to show you anyway. Again, need some room, Dan. Come on. If you just had a capacitor, there's no load for it to discharge through, is there? So obviously, it's just going to be a straight line. Simple as that. There you go. Straight line, 0.7 less than the P, because that capacitor is never going to discharge. Okay, I can't see an application for that because obviously you need some sort of load to which would be something like, I don't know, it could be a charger, mobile phone charger, but some sort of resistance. Okay, full wave rectifier is this one here. How does a full wave work? Well, the disadvantage of the half wave is you're wasting half of the wave, aren't you? You're chopping off half of the wave. So this is why we use a full wave one. Okay. So have a look at what's going on here. I don't think this one works. It doesn't show it very well on this one. No, it doesn't because of the grounding issue. See if we can stick a ground on. Where are we? See if that helps anything. Yeah, it's not bad actually. It's not bad. Ignore the red one. In fact, I'll take the red one off. The red one's the normal input signal, but hopefully you can see, moving that up, that you get this kind of the negative part of the signal of the red one goes up. So it basically gives you that signal there. Okay. Just so you can see how you draw it in the exam, if you ever get this, you have two diodes facing towards each other. That one's facing towards that one. Two diodes facing away from each other. And again, in fact, I'll show you on this. Will be a bit easier when we trace through what's going on. I want this one now. So let's have a look. Ooh. So you guys have got this, and I'll send you this anyway. There we go. You can see the idea of the way that the current travels through here. But the idea is it would only ever go through two diodes. So this voltage will be 1.4 volts less than the peak. Okay. What else do you need to know? Let's move up a bit. I told you about, and that's okay. We've got that one. Explain that. Oh, that was it. Yeah. The ripple voltage, there's an equation there which is on the data sheet to work out ripple voltage. So there are all the values there. So you can work out ripple voltage as well. There's an example there. Basically, your task is a recap essentially. You can't do the investigations, forget that, but you can do the exercises. So exercise 7.1, you can do this. You can build a half wave rectifier. Yeah, look above. You can calculate RMS. I've just showed you how to do that. If you know the peak value, there's an equation to do that. And you should be able to do some sketches. So you should be able to do that one. The next bit, exercise 7.2, is using something called a Zener diode. Again, we have done lessons on this before. A Zener diode, you actually deliberately connect the wrong way round, and it essentially clamps a specific voltage across it. So this particular one has got 7.5 volts across it. But if it's a 12-volt power supply and you've got 7.5 volts across there, obviously VR would therefore be 4.5 volts. And then the rest is literally series circuit, or series and parallel circuit rules. So the current coming down there, IR, is going to be split between IZ and IL. So IL plus IZ, the current there, plus the current there, will obviously equal the current there. It's showing you how to do that there. Look, you can see all these calculations. It's showing you how to do that. So going back onto here, again, you can't do the investigation. You probably could if you use crocodile clips. It's up to you. But the main thing I want you to do is to do the exercise. Here's the exercise. It's using series and parallel circuit rules. You can label up the currents. You can say, look, I know what the current down here is. I've got 5.1 volts there, so I know what the voltage there should be. Should be 9, take away that, and so on and so forth. So you should be able to work out those values. And then finally, I just showed you the full wave rectifier here on the crocodile clips. Again, it's got some calculations here. Look, you know that equation from before. I said to you about 1.4 volts being lost because it goes through two diodes at any time. You take off 1.4 volts. Again, you've seen that equation before. It's got an example there, but you have seen that equation before. That's the ripple voltage one. But the main thing is, I want you to try exercise 7.3 as well. So you've got three exercises: 7.1 on half wave, 7.2, which is on the Zener diodes. Just think series and parallel circuit rules. That's all it is. And obviously, exercise 7.3, which is full wave, probably a bit trickier. But again, think about it, use examples. But again, just put it on Teams. You say, look, Dan, 7.3, B part II. I'm not quite sure what to do, and I will answer that. I will help you. Okay. So I'm only giving this one task this week. Okay. I think that's about all I wanted to say about that. So stop.